Okay, in this video we're looking at the rational zero theorem. And what that says is that if you have a polynomial, such as this one, you can take the factors of the constant term, which in this case is 10, divided by the factors of the leading coefficient, which the leading coefficient is the coefficient of the highest exponent, so it's 1. So you have the possible factors of this polynomial are plus or minus p over q. So in this case, let's go with this one. I've got factors of 10 over 1. So I have plus or minus, one factor of 10 is 1, so 1 over 1. Another factor of 10 is 2, 2 times 5. So I can say plus or minus 2 over the leading coefficient, which is 1. Another possible ratio of factors is plus or minus. We've taken a factor of 1, a factor of 2, let's see, a factor of 5, so plus or minus 5 over 1. What else do we have with 10? 10 itself. So we have plus or minus 10 over 1. Of course, when you divide by 1, it's just that number. So let's just take these out. These are our possible factors for this polynomial, if we want to factor it out. And how do we check them? Well, the best way is probably to do a graph and then look at the graph and see which ones of these could potentially cross the axis where y is 0, be an x-intercept. So if we have some graph like this, we would look and see, well, approximately where are these x-intercepts occurring? And then we'll test them using synthetic division. So we're going to test using 1, x equals 1. So that's one possible factor. So it would be like an x minus 1 factor. So we'll use the x equals 1. So we'll put that over here for synthetic division. And then we'll take the coefficients of this polynomial, which are, and it has to be in standard format. So it's 1 minus 4 minus 7 and 10. Alright, so synthetic division, we carry the first coefficient down. We multiply it times 1, we get 1. Minus 4 plus 1 is minus 3. 1 times minus 3 is minus 3. Minus 7 plus a minus 3 is minus 10. 1 times minus 10 is minus 10. 10 minus 10 is 0. So we have a remainder of 0, which means that it did factor evenly into the polynomial. So one of the factors of the polynomial is x minus 1. So what we have at this point is we have the x minus 1, and we take a look at these numbers here, and the 1 will be 1 less than the exponent, the highest exponent, so that would be an x squared, 1x squared, minus 3x, and then minus 10. I have to excuse my writing here. We don't need the 1 in there. So here was the binomial factor, and here's the trinomial that's left. Now, with the trinomial that's left, we may be able to factor it further. And I'm not sure on this one, but one technique that you can use, I can use an X diagram, and I'll put a minus 10, the C value here, and the B value is minus 3. And then what factors multiply together to get minus 10, but sum together to get minus 3. So that would be, minus is going to dominate. So I'll say minus 5 plus 2. That would work. So actually I can replace this trinomial with an x minus 5. Running out of room here. X minus 5 times x plus 2. X plus 2. And we had this x minus 1. That didn't change. So that's still in there, x minus 1. So we ended up with x minus 1 times x minus 5 times x plus 2. Now we have it fully factored.